Hi Srivatsa. I am discussing today regarding the machine learning, the basic concept. So instead of going directly for recording, so we will see just first initially what will be the machine learning and what is the basic concept related to that, and then we will go on whatever the code or how we are dealing with the data and how to predict the models. All those things we will see it in the data. But when you are coming for the initial machine learning, so it is a subgroup of artificial intelligence. So if I say artificial intelligence is one of the main uh, C, we can say, in that are subgroups like a machine learning. The machine learning inside as a neural network will act as a subgroup, and after that, inside the neural network, deep learning will act as a subgroup. So, what are the difference between these things? So, what is artificial intelligence? Basically, many are having confusion with what is artificial intelligence. What is the difference between artificial intelligence and the machine learning? So, artificial intelligence, as the name itself indicating, like it is artificial intelligence, means something which is externally intelligence model. So we are giving the data, we are training the model so that it will having a capacity to predict the future, whatever the data it will be getting. So we can say that out of the artificial intelligence, very vast area it is. We can classify as expert systems or natural language processing, search algorithm, and one type is machine learning. So that's why I have told that machine learning is a part of the artificial intelligence. So even expert system is doing the same artificial intelligence what it will be doing. So all these are related to artificial intelligence, but based on their properties, they are classified with the different groups. So one which that type of is machine learning. So what is machine learning? Machine learning is, again the name is itself will be defining the machine learn is model trained. So whatever the model learn from the data and predicting the future data, so that model we will call it as a machine learning. So means if I say like one, because the machine learning there are several machine learning models. If I want to say the several machine learning methods are available. If I want to name it, the logistic regression, linear regression, KNN, K-neighborhood, and decision tree, random forest, XGBoost. So there are different sets of machine learning methods. All these machine learning models, which are trained either with the statistical way or with the analytical way, and the different types how we are dealing with the data. Why we are dealing with the data, I will explain you later. So we are coming for that. And if I am not using this type of statistical tools or statistical method or analytical method to deal the model, if I am not using that, I have to define my own analytical or statistical method for dealing that type, dealing with the one type of data. That type of model we will call it as neural networks. Means the networks which are trained by us with a defined our own customized way. So that we can say. So means the neural networks having a capacity to customize. So that type of models we will call it as neural networks. And if our neural networks are, there are like several neural networks are there. We can say it is pre-trained neural networks or the deep learning neural networks. So one type is deep learning, because the neural networks which are with their single layer, if we are not able to do the things, so then we can customize such a way that with it adding different number of layers or different number of I can say that different number of layers with a different activation functions, so that it can interpret the whatever the input given by the user, and it can due to the layers, number of layers and activation function, different activation function, it will get the ability to predict the future data. So that type of model we will call it as a deep learning model. So there are difference between these type of models. Okay. So we will see first why this machine learning is needed, because we are on the coming days we will see all the neural networks or deep learning, whatever it will be. First we will start with the machine learning. So it is one of the subset of the artificial intelligence. Why this machine learning is needed? And before going for that, there are several types of machine learning as I have defined. So there are supervisor and unsupervised way the machine learning is classified. Supervisor we will call it as a classification and regression, whatever I have defined at that time. So they are coming, some of them are coming in the classification and some of them are coming in the regression, some of them are coming in the clustering, all those things. So if I want to say that classification, when you are predicting the category, given the data, they gave the data and they are told to predict the data to some category. So that type, that point of time the classification will come. And if means again why I am saying that supervised learning as having this type of category, because supervised learning itself, they are providing the data and they are providing the label, means name, person with the name. So that type of data we can easily classify it. So when we are classifying, we are getting these two types of algorithms. One is classification algorithm, one is regression type algorithm. Regression, what it will do, we are giving this one set of data and it will predict another set of data. So that is, we will call it as a regression. Okay. And if that input data will be best fit for the output, then we will call it as a good fit during the regression. And when we are coming for the unsupervised learning, there are three different ways, like clustering, association and dimensional reduction. So I will briefly tell you, we will see later on what are these things in detail. The clustering, so segregating with the similarities, means we can say that grouping with the similarities of the data. So that we will call it as a clustering. And association is nothing but the data for that which one will be suitable, means adding the data which are suitable for that. So that type of we will call it association. And dimensional reduction, it is a generalization we will call it as. So making as a outfit which are the best outfits, means if I have random data, which are the best fit for that data. So that we are selecting. So that is, we will call it as a generalization. So we will see that all those things in the later when we are dealing with the particular topics. So why this machine learning is needed? Why these type of methods are needed? Because if I consider simple data, so as I am showing over the figure, so you can see over here the wave, which is look like a sine wave, we can see. So data, if it is in this way, I have to predict the output, what type of data it is. I can directly write the estimated curve, like sine wave curve I can write it. Means for certain x, I can easily predict the function of x, and from this function of x, I can easily get the output, that is yi, right? So practically this type of data we won't get for the machine learning, because these are, we can solve it with easy methods or whatever mathematical methods which is available, so we can solve it easily. But if the data are like in this way, there are like variation in the curve. See, when you are seeing over here, that whatever the data points which are plotted over here, so they are not in the linearly related. So one is over here and one is over here, one is over here, one is over. If I apply the previous method directly, x is y is a function of x, then I will get the curve like somewhat in a different shape, right? So here what happened is some noise data are added, means a practical data, whatever the data we are getting from the instrument or the sensors, they are having some noise built in that data. So I have to segregate that noise first, then I have to write it, or I have to write a function such a way that that model itself or the function itself having the ability to segregate the noise data and it should predict the output data. So that is what the machine learning is doing. So xi, when I am defining the y of x, y function, that is output prediction function from this type of data, you can see over here my input is xi and I am having a function with some noise is adding. So I have to deal effectively with this noise and such a way that I have to get a proper output. So this is what the basic concept of application of machine learning. So here a small example which I am explaining over here is one of the famous examples when we are dealing with the machine learning, that is iris data classification. We know that iris flower, there are here we have selected three types of iris flower. One is setosa and versicolor and virginica. So these three types of iris flower we have to classify based on their sepal length, sepal width, petal length and petal width. So these are some of the data. Okay. So you can see over here how the data are varying and the classes are defined. So since, as I told, the class is defined and data are defined, so this is purely a supervised learning method. Okay. And when we are dealing with, if I want to see the correlation between the data, you can see over here the correlation of the data which I have made a heat map. So over here the correlation of the data with respect to that same sepal length and sepal length, where they are having good correlation. The correlation bar over here, the worst to best. So you can see how worst correlation of the data means sepal length with respect to sepal width, how the worst it is, and sepal length with respect to petal length, how it will be the correlation, and sepal length with respect to petal width, how the correlation. So this correlation will help to choose the model. Okay. So if you want to visualize, I have here the bar chart. So sepal length data are varying from 4 to 8, somewhat 4 to 8. The major data are lying from here 5 to 6.4 somewhat. Okay, 5.1 to 6.4, the mean over here. So, and sepal width same way, but the data are lying from somewhat the 2.1 to around some minor data around the 4 and major data are end with here 4 and the majority of data are lying from 2.9 to 3.3. Same way over here and here. So this is only for your visualization. I gave the picture how the data are varying with respect to that data set. And you can see over here the same bar chart I have plotted over here, the data how it will be lying. And if you want to see the correlation between the data, so how the worst relations, they are having very segregated data sets, means one data set in that side and one data set will be lying in this side. So if you are if they are having good correlation, you can see over here somewhere like over here it will be having merged, but that is a total values. Okay, no issue over that. And some here you can see over here the sepal length and petal width. You have seen in the heat map, it is showing around 0.84 correlation, and how the data are lying over here. So there is identification of these data is very difficult, right? So for that we are defining the models. I have defined some of the model over here. So we are explaining one by one over here in the later coming days. First we will see how these models are behaving. Just see the picture, that's it, that is enough. See the different algorithms which I have defined here is logistic regression, linear discriminant analysis, K neighborhood and decision tree, Navier Bayes, SVM. So these are different algorithms, machine learning algorithms. They are the modules. So we are using that to predict. So that is what the limitation. So we have certain control to change the module, but we don't have free hand to change the module of the SVM. For that we have to write our own algorithm. And you can see, you can compare the results of the data. Means these some of the modules are dealing the data with the statistical method, the some of the algorithms are dealing with the analytical method. So when you are seeing over here, the SVM is showing around 98% accuracy, and linear regression is showing 94% accuracy, then logistic regression is showing 94% accuracy, and linear discriminant analysis is showing around 97% accuracy. So like in this way the accuracy is varying. So based on these accuracies, which will be the best suitable? So that is trial and error method. So which will be the best suitable? We can predict it, which is the best algorithm also. That I will discuss you in the later part. But now, if I compare the SVM with other modules or other machine learning algorithms, so SVM will be the best. So it is showing good accuracy or good correlation between the data. So it is easily classify the data with a different way, which is having iris setosa or iris virginica or iris versicolor. It is having best effective way to classify it, 98%. So this is what the simple example for machine learning. This is what the basic concept of machine learning, how it will be working. Okay. So now we will see one by one what it will be and how it will be acting, what is the mathematical relation between behind the model. All those things we will see one by one. Thank you.